Hello everyone. Well, myself Dr. Rajeshwari HV, working as an assistant professor in chemistry, JSS College, Gokak. This is my sixth video on thermodynamics too. Now, in this video, let us know how to derive the Gibbs-Helmholtz equation. So, let G be the free energy of the system at temperature T, that is the initial state. Now, suppose the temperature changes from T to T plus dt, where dt is a very small, that is infinitesimally small change in the temperature. Then the free energy change at the new temperature, that is T plus dt, is given as G1 plus dG1. Okay, so now at initial state, if G is the free energy change, free energy at temperature T, then at temperature T plus dt, the change in free energy is taken as G1 plus dG1, where 1 represents initial state. Now suppose that when the system is in the final state, then its free energy will be given by G2 plus dG2 at temperature T plus dt. Okay. Now if the pressure remains constant all along this process and free energy function is also given by the equation, that is dg is equal to vdp minus sdt. Now according to this expression, when dp is constant, the change in pressure is 0, then the expression reduces to dg is equal to minus sdt. Then we can write for initial state dg1 is equal to minus s1 dt, and for the final state dg2 is equal to minus s2 dt. Let us take the first one, initial state, as equation number 1 and final state as equation number 2. So where S1 and S2 are the entropies of the system in the final and the initial state. 1 represents initial state and 2 represents the final state of the system respectively. Well, let us move to the next part of the derivation. Now subtracting equation 1 by 2, then we have d into g2 minus g1 minus a minus of s2 minus s1 and dt. So you have to subtract equation 1 by 2. Then we have this expression. Since change in free energy, that is g2 minus g1, is taken as delta g, and delta g is change in free energy, so is equal to minus delta s, and delta s is nothing but s2 minus s1, the change in entropy, into dt. Now as the pressure is constant, therefore, so we can write the same expression, rearrange the same expression, and you have to bring the term dt towards the left hand side to the denominator. Then we have d by dt of delta g at constant pressure. Why it is taken as constant pressure? Because in this process the pressure is kept constant, is equal to minus delta s. So this is taken as equation number 3. And we also know that the free energy function, that is delta g, is also represented using the expression delta g is equal to delta h minus t delta s. Rearrange this expression for minus delta s. So minus delta s is equal to delta g minus delta h divided by t. Okay. So this is taken as equation number 4. Now equating, you look into the equation 3 and 4. Both expressions are for the change in free energy, negative change in free energy. So we have to equate equation 3 and 4. Then we have delta s is equal to dg minus delta h by t. It is written over here. Then minus delta s is equal to d by dt of change in free energy at constant pressure is written here. The equation 4 and 3 is equated here. Now rearrange this expression for delta g, because I have to find out the change in free energy. So when the change in free energy is represented using the expression, right? So this is the, after equating equation 3 and 4, you have to equate equation 3 and 4. Then we have this expression delta g minus delta h by t is equal to d by dt of delta g at constant pressure. So rearrange this expression for the change in free energy delta g. So then we have delta g is equal to delta h minus t into d by dt of delta g at constant pressure. So this is another form of Gibbs-Helmholtz equation, and this will be a very important derivation for the 5 marks question. Well, these are the important expressions you need to remember to solve the problems. So, the free energy function can also be given by different equation. The first form is delta G is equal to delta H minus T delta S. Then second, dG is equal to VdP minus STT. Then H is enthalpy, H is equal to U plus PV, U is internal energy. And fourth one is V is equal to dG by dP at constant temperature and minus S is equal to dG by dt at constant pressure. And the free energy is also represented using the expressions, that is equation number 5, delta G is equal to nRT log natural log P2 by P1. This is another form of the free energy. Free energy also depends on the pressure here. Or we can write delta G is equal to nRT natural log V1 by V2. Since pressure and volume are inversely proportional to each other, so if it is pressure, we write P2 by P1. Then it is volume, then we write V1 by V2. So equation 6 is the Gibbs-Helmohltz equation. Another form of expressing the Gibbs-Helmohltz equation, that is delta G is equal to delta H minus T into d by dt of delta G at constant pressure. Now hope the different forms of the free energy have been expressed here. Now this will be an important question, the repeatedly asked question in the examination. Derive Gibbs-Helmohltz equation for a 5 marks question. So you have to derive the sixth form of the Gibbs-Helmohltz equation, so which has been shown to you in the video. Now let us solve a few problems based on the Gibbs free energy. The first problem, calculate the free energy change during the expansion of 3 moles of a gas from a pressure of 101.3 kilopascal to 1.013 kilopascal at 300 Kelvin. Okay, so this is the problem given. The gas is expanding, so you have to see whether it is expansion or compression. Remember, when there is expansion, the pressure decreases from the higher pressure to lower pressure and the volume increases from the lower volume to higher volume. So whenever there is expansion, the pressure decreases and volume increases. So you should remember this concept always. Now for this problem, I need to calculate the free energy change. So I have to use the expression delta G is equal to 2.303 nRT log P2 by P1. So this is the form. In the natural log, if it is converted to logarithm, they have to multiply the equation by 2.303 nRT log P2 by P1. This is another form of the same expression written in terms of natural log. Let us use this form. Now P1 is given 101.3 kilopascal. So because initial pressure is 101.3 kilopascal, P2 is the final pressure 1.013 kilopascal. The temperature is 300 Kelvin. The R value is taken in terms of kilojoules. It is 8.314 into 10 raised to minus 3 kilojoules per mole. Then substitute all the parameters into the expression. Then we have 2.303 into 3 in place of N. We have taken 3 because the number of moles given here is 3 moles. And R value is substituted here. Then temperature is 300 Kelvin log of P2 by P1. So P2 is the final pressure and P1 is the initial pressure. Substitute and solve it, and the change in free energy is minus 34.46 kilojoules per mole. Then the change in free energy is given as minus 34.46 kilojoules per mole. So well, let us move to the second problem. This is the problem given. Calculate the free energy change which occurs when 1 mole of an ideal gas expands reversibly and isothermally at 300 Kelvin from the initial volume 5 liters to 50 liters. So the volume change is given. So the expression we have to use is delta G is equal to nRT natural log V1 by V2. If it is pressure, we write P2 by P1. If it is volume, V1 by V2, because pressure and volume are inversely proportional to each other. So natural log is converted to logarithm, then we write the expression delta G is equal to 2.303 nRT log V2 by V1 by V2. So N is equal to 1, the number of moles is 1, and V1, that is initial volume is 5 liters, it is going to 50, the final volume is 50 liters. since it is an expansion, the volume should increase from 5 to 50. Then the R value is 8.314 joules per Kelvin per mole. It is taken in terms of joules, and then substitute in the value. We then substitute in the expression. We have delta G is equal to 2.303, and in place of N you have to write 1. There is 1 mole, and R value is substituted here into temperature 300 Kelvin log of 5 by 50, that is V1 by V2. If you solve it, then we have the final answer, that is minus 57,5744.1 joules or minus 7.44 kilojoules per mole. If you convert it for kilojoules, then it is minus 5.744 kilojoules per mole. Remember, delta G is negative. Delta G should be negative here. So if delta G is negative, then our reaction is said to be spontaneous. So it is a note. Remember, when the gas is undergoing expansion, the volume increases and pressure decreases. When there is compression, then the volume decreases, then the pressure increases. Now let us move to the third problem. The free energy of formation of a water at 298 Kelvin and 308 Kelvin are minus 237 kilojoules per mole and minus 235.2 kilojoules per mole respectively. Calculate entropy of formation of the water. So we have to find entropy here, and they have given the free energy formation for the water at different temperature. Now, so this is the expression that we require, because we need to find out delta S. So delta G is equal to delta H minus T into d by dt of delta G at constant pressure. Now since d by dt of delta G is at constant pressure is nothing but the change in free energy at different temperature. Delta T means T2 minus T1, and delta G is delta G at temperature T2 and T1. And this expression is written in the expanded form. So T2 is the higher temperature, is 308 Kelvin. T1 is the lower temperature, 298 Kelvin. And 308 minus 298, that is T2 minus T1. And substitute the free energy formation at temperature 308 is given according to the data. It is minus 235.2 kilojoules, minus 235.2 kilojoules per mole, and the free energy formation of water at 298 Kelvin is minus 237 kilojoules per mole. So minus of minus will become plus. So and 308 minus 298 is 10 Kelvin, and if you solve this, then we have the final value 1.8 by 10. It is 0.18 kilojoules per mole per Kelvin. So this will give the d by dt of delta G at constant pressure. So d by dt of delta G at constant pressure is 0.18 kilojoules per mole per Kelvin. So we know that delta G is equal to delta H minus T delta S. This is another form of Gibbs-Helmohltz equation. So when you compare this equation and the equation written over here, the second term, the first term is same, delta H and delta H. See the second term. This second term can be equated to minus T delta S. So if T is common here, the term in the bracket, that is d by dt of delta G at constant pressure, is taken as delta S. So that's why I can equate d by dt of delta G at constant pressure to minus delta S. And we know the value of d by dt of delta G at constant pressure we have calculated in the previous step as 0.18 kilojoules per mole per Kelvin. Substitute in the expression. So then minus delta S will become equal to 0.18 kilojoules per mole per Kelvin. Then we have delta S is equal to minus 0.18 kilojoule per mole per Kelvin. So it is the entropy of formation of the water. So we have solved 3 problems based on free energy change. Thank you.